Hello everyone, welcome to the ZW3D Get Started training series. In this video, let's talk about sheet metal. I'll introduce the commonly used commands and the key differences between ZW3D and SOLIDWORKS. Without further ado, let's move on to the software. Looking at the toolbar, you'll find all the essential tools for sheet metal design, including base, flange, edit, corner treatment, forming tools, unfolding and flatten tools, as well as the conversion features. With these functions, you can efficiently create and modify sheet metal parts. Now, let's get started by remodeling one of the parts from the projector. When you start a sheet metal part, it's recommended to set the global attribute, including thickness, radius, default flange position, length type, K-factor, and so on. Global attribute can greatly reduce repetitive manually input each time and allows for batch modification if needed. Now we are ready to do the modeling process. For sheet metal, normally we build the base in the beginning. In ZW3D, we have two separated commands, respectively for tap and flange. While in SOLIDWORKS, they are combined as one command. Different approaches, same result. Now let me quickly show you how to use these two commands. For extrude tap, all that required is a closed profile. For extrude flange, we need to draw an open profile. And it will create a shape with multi-flange at one time. Now let's continue modeling the part by adding two flanges to the left and the right side. In ZW3D, you can achieve that same result using three different methods: flange, full flange, or flange with profile. I always recommend you to use flange with profile for any linear flange creation, including the ones we are doing now. And I'll take you go through the key parameters and operations. The first one is the flange position. You can decide whether to put the flange outside the edge or inside the edge. And also, bend radius is one of the most important values. You may notice that the value is not allowed to change. The reason is because we have defined the global values a little while earlier. If you really need to change to a different value, just click Dynamic Input command in the drop-down menu to unlock it. Then you are able to make change. The same logic works for K-factor. You can either follow the global settings or define the K-factor locally. Now we can make a fillet to the corner of the edge. Similarly to solid modeling, we use window pick to pick the edges we want to add the fillet to. Now let's continue. Next, we need to create a special shape flange. As I mentioned before, we can always use flange with the profile for any linear flange creation. In this case, we need to do further edit to the profile. Now we are into the sketch environment. We can make some changes to the height and the width of the flange. And we add more dimensions to make it symmetric. Okay, now we made more modifications. Okay, now the sketch is already done. We can finish and get the result. And now we have only one more flange to create. Since it's a partial flange with circular edge, so the best way to use the flange command. Here I can align the model to the XY plane and ignore the sheltered edge in the backside. Then use window box to select a set of tangent edges in the front side. Then we just need to set the start and end distance of the flange. And also the length of the flange. Here we'll make it 5 mm. Okay, click apply. By now the flange is all created. We have only a dimple left. In ZW3D, it's got a very handy tool to create dimple. We just select the locating plane. Then create a sketch. Draw a circle. And of course, the dimple command works not for only circle, but also like a rectangle and other shapes. Now let's exit the sketch to get the dimple preview. And here we can switch to open dimple and make some modification to the parameters. Okay, done. For the other side, we just need to use the mirror feature. Select all the 3 features. And also the datum plane to mirror. Then we can get the identical result on the other side. Now the part is completed. Next, I will introduce more frequently used commands. The first one is hem flange. Similar to SOLIDWORKS, it can create different types of hem flange according to user requirements. Another command I'd like to introduce is fold by line. In SOLIDWORKS, it's called sketch the bend. As its name suggests, you can create a bend by a line. All we have to do is draw a line. And select locating plane. Click OK to get the result. And a similar command is jog. The main difference is its jog command will create 2 bends instead of 1. Here we also create a line and define the plane. Okay. Now we need to reverse the side. Okay, we'll get the correct result. Another command is Lofted flange, which is commonly used to create ventilation adapters, such as round to square duct. Now let me show you how to use it correctly. Firstly, I shall create a circle and a rectangle in 2 datum planes. In ZW3D, the Lofted flange command has 3 different subtypes. The first one is general loft, which creates a thin-walled solid. However, it doesn't meet sheet metal manufacturing requirements and cannot be unfolded. For sheet metal design, we mainly use the second and third types. Both generate sheet metal parts that can be unfolded. This corresponds to formed and bent options in SOLIDWORKS loft flange command. depending on the manufacturing process used. Now, let's take a look at the second type. The operation is very simple. Just select two profiles. Define the thickness, bend radius, and the K factor. I'll use default values here. Then, we define the cut. This is where ZW3D is more convenient than SOLIDWORKS. You don't need to manually add the opening in the sketch. Instead, you can simply select the cut points and set cut size directly in the command. And once we align the direction, then we can get the preview. Now we apply. And we can check the unfolded result. Next, let's move on to the third type. Again, we select two profiles and define the cut points. This time, let's reverse the thickness direction. Finally, based on company's requirements, you can define the bend using maximum arc height, number of bends, maximum arc chord length, or maximum arc chord angle. Here, I'll use the number of bends to generate the result. And of course, the type can also be unfolded. Another command I'd like to introduce is close corner. The close corner command in ZW3D is used to close the gaps between sheet metal bends, ensuring a seamless connection between adjacent flanges. This is crucial for improving part strength, simplifying manufacturing, and achieving better aesthetics. ZW3D provides multi-closure types, allowing to choose the best option based on manufacturing requirements, such as natural, overlap, and underlap. You can also define parameters such as gap distance and the relief type to control the final shape of the corner. Okay, that's all I'd like to introduce for the flange commands. Next, let's dive into the forming tools. I have showed you dimple command a while earlier, so now I will introduce lower command. Taking this door as an example. Now we can call out the command. Assign the face. Then create a new sketch where the lower path is located. Then just draw a single line as the path. Add dimensions and constraints. Then exit the sketch. You can quickly get a lower. All you need to do is adjusting the parameters. Besides, we can use pattern feature to make a bunch of lower within 5 seconds. Now let me show you. Select the lower, define the direction, and define the numbers and the distance for the pattern. Okay, get the final result. Except for dimple and lower, other stamping shapes can be created using the punch command. In this command, you can either use an existing shape as a punch tool, or you can call an existing punch or user-defined punch from the punch library. First, I will demonstrate how to create a stamp shape using an existing solid as a punch tool. Here I already created one shape for the punch. And we select the face where the punch will be. We select the face and we set the punch, and we define the open faces. OK to get the result. Next, I will demonstrate how to add a custom punch to the library and how to use it. In fact, the process is very simple. Now I already designed one punch. And I create a new folder under the standard parts. I name it ZWSoft. And I open the source folder. And I copy the path. Okay, now all I have to do is save as the parts into the path we just copied. We gave it a different name. Save. Okay, now it's done. We can refresh to see the result. And now let me show you how to use the punch we have added to the library. Just double click. And then we can position the punch by different methods, points or constraints. Here we use the constraints. For example, I will show you how to add the constraints. Select one face of the punch. Here we use the side face and also the side face of the sheet metal part, and define the offset distance. Here we can make it bigger. Okay. And remember to add the constraints to the list. And then we are able to add more constraints. Okay. And then define the plan. We can either define the bottom face or the top face. In this case, it should be the top face. And then define the open faces. And OK to get the result. So the whole process is very simple and very convenient. And when design is finished, we need to get the flat shape and the drawing for manufacturing. In ZW3D, there are two main ways to unfold the sheet metal and get the 2D drawing. First, we use the unfold. And ZW3D will automatically calculate the bends and generate the flat model of the sheet metal part. Once unfolded, we can open the drawing module, create a new sheet, and insert the model view. And we can decide whether to show the bend line and the bend node. Here I will go with yes. Now the unfold view is already created. After putting necessary dimensions and annotations, we can export the drawing as DWG or DXF file for manufacturing. Method 2, using flatten feature. We can use the flatten feature to directly generate a flattened representation and also flat pattern. Here we already get it. And it works for multiple sheet metal. Finally, export the flattened model as DXF or DWG by saving the flattened pattern view. In the end of the video, I'd like to share a small software skill to convert imported sheet metal parts and generate a flat pattern for manufacturing. The process includes recognizing sheet metal feature, converting the model, and unfold it for detailed drawings. Let's go through the steps. After we import the sheet metal file, we can use the direct edit or healing to clean up the geometry. And we use mark bend tool to detect bends and thickness. If some bends cannot be detected, you can edit manually. Here we have one. Okay, we can apply. Now it's already a sheet metal part. And you can see the flat pattern and the flat shape will be generated automatically. Then we can export the drawing as DWG or DXF as previously doing. Alright, that's all I'd like to cover for this video. Thank you for watching.